So in today's session, I'm going to explain how to solve several questions in practice question 1. If you have any question during the session, you can just ask me, speak to me directly, or you can use chatting window to ask me any questions. So let's talk about the first questions. Baker-Hardwick, chapter 2, question 1. So spend just 10 seconds to read this sentence. The question: MMP need to buy 1 million Swiss franc CHF to pay its Swiss chocolate supplier. Now the banker quote B, that's great. So banker here is a dealer. A quote B then S rate of this one. Now how do we interpret this symbol? The first one here, this is the bid rate. This one is the ask rate. So bid price of USD CHF. Why I'm calling this as a USD CHF? Because USD is in the denominator, CHF is in the numerator. First three letters in the denominator, last three letters in the numerator. Bid price of USD CHF is this one. Ask price of USD CHF is this one. Now, what is the interpretations? You should memorize this one. In terms of dealer point of view, banker point of view, banker buy USD, the currency in the denominator, 1 USD with this amount of Swiss franc. What is the interpretation of ask price? Dealer sell the currency in the denominator, 1 USD, with this amount of Swiss franc. Is this okay? Then, so MMP is here, banker or dealer is here. What MMP is trying to do is the paying USD, certain amount of US dollar, and getting CHF 1 million. Now, in order to solve this one, you need to know what dealer is trying to do. So MMP buy 1 million Swiss franc. In terms of dealer point of view, dealer is selling Swiss franc for getting US dollar. Is this clear? Dealer is selling Swiss franc for buying USD. So what is going to be the price for these transactions? So dealer is selling CHF for USD. Which price? Bid price or ask price? Dealer is selling Swiss francs. That means ask price. Is this clear? So MMP is customer buying Swiss franc. Banker dealer is selling Swiss franc for getting USD. So the price should be ask price of CHF USD. Dealer sells Swiss franc at ask price of this, $4. So again, just I'm writing this one here. Dealer buy Swiss franc for selling dollar at the bid rate, bid price of CHF USD. Dealer sells Swiss franc for buying US dollar at the ask rate of CHF USD. In this transaction, dealer, bank, selling Swiss franc for buying dollar. So we have to use ask rate of CHF USD. Dealer is selling Swiss franc, $4. In order to get the USD amount, we have to multiply 1 million Swiss franc by ask price of CHF USD. Then CHF will be canceled, and we're gonna get dollar amount. If you have any question, just use the chatting window or speak directly to me. The problem is we don't know ask price of CHF USD. It's not given directly. However, we know that bid price of USD CHF is this one. That was the interpretations. Ask price of USD CHF is this one. Given this, can we compute ask price of CHF USD? We already learned this one. This is the reciprocal of this, right? So in summary, you're trying to compute dollar amount or 1 million Swiss franc. So 1 million Swiss franc times ask price of CHUSD, which is the reciprocal of the bid of USD CHF. So we're going to write down this one here, and Swiss franc will be canceled, and we're going to get this amount of dollar. So instead of writing down like this, I can write like this. If you're not sure, you can heuristically interpret this one as the USD, the one divided by this one. So this one's here, this one goes here, right? So it's like a USD 1, CHF 1.399. So I write down this one as 1.1399 and CHF USD. Oh, sorry for that. CHF USD. That's how I write here. So often, for computation purpose, instead of putting CHF USD here, it's maybe easier to put something like this. First, write down the number, and then express what is this. This is the exchange rate CHF USD. Anyway, so we're just computing this one, and you get dollar amount. So this is the answer for first question. Any questions? So given CHF, given USD CHF, bid and ask price of USD CHF, we just analyze what dealer is doing in these transactions. It turns out dealer is selling Swiss franc. So we need to use ask price of CHF USD. Dealer is selling this one at ask price. We got that as a reciprocal of bid of USD CHF and just simple computations. That's the question one. The question two, if the Japanese yen US dollar exchange rate is this one, so for $1, you have to pay this amount of yen. It is too difficult. So I need to assume that you know everything in review slide for lecture 1 at least. Anyway, if the Japanese yen US dollar exchange rate is this one, and if it takes 25.15 Thai baht to purchase $1, what is the yen price of the baht? So this is how we use cross rate formula to compute the exchange rate, certain exchange rates. So we have two exchange rates involving US dollar. We're trying to compute the exchange rate between non-US dollar, yen versus Thai baht. So the first one, this one, we use the symbol. Dollar is in the denominator, so it's the first three letters. This one just means USD JPY is equal to 104.30. And what about this one? We need to pay this amount of Thai baht to get $1. That means just this one. For $1, you need to pay this one. For $1, you need to pay this amount of yen. That's our usual interpretations. Now, what you need to compute is the yen price of the baht. What is the meaning of yen price of the baht? This is something like dollar price of an apple, which means, let's say $1 per one apple and $1 per apple. This one is translated into this form, right? Dollar price of an apple will be looking like this. $1 divided by apple, right? So yen price of the baht means baht should be in the denominator. So this one means something like how many yen you need to buy one Thai baht. So THB, JPY. For one Thai baht, how many yen you need to pay? So we are supposed to compute THB, JPY. So you should be able to interpret this one into this form. For one Thai baht, how many Japanese yen you have to pay? Now, how do we get this one? It's very easy, right? Just cross rate formula. Dollar will be canceled, and you're gonna get THB JPY. So always you just put USD between THB JPY. That's the cross rate formula. So what is this one? THB USD. We don't know that, but we know USD THB. How do we compute this one? Reciprocal. So the reciprocal of this one is going to be THB USD, and USD JPY is given. So the reciprocal of this one times USD JPY, you get these expressions. So for 1 Thai baht, you have to pay this amount of yen. That's the question 2. Any question? All right. Let's go to question 3. In question 3, as a foreign exchange trader, you see the following quote for Canadian dollar CAD, US dollar USD, and Mexican peso MXN. We have 3 currency, and 3 prices are given, 3 exchange rates are given. 1 Canadian dollar, you need to pay this amount of US dollar. For 1 Canadian dollar, you have to pay this amount of Mexican peso. For 1 US dollar, you have to pay this amount of Mexican peso. So I'm going to use this form. Why I'm using this form? Because this form is easier to deal with when you think about triangular arbitrage. So instead of using this form, I'm writing down like this. So CAD USD is 0.7047, just meaning is same as this one. For 1 Canadian dollar, you need this amount of US dollar. So for this guy, I can write down like this. For this guy, I can write down like this. Now, once you get these 3 expressions, even though I'm not giving you any information, you should be able to compute USD CAD, MXN CAD, MXN USD. Just reciprocal, right? You should know this one. Now, the question is, we need to find out if there is an arbitrage opportunity. So we're going to use triangular arbitrage here. And if so, how would you exploit it if you have 1 Canadian dollar? What is going to be your arbitrage strategy? So we need to first find out if there are 2 prices or 1 same transactions, right? So if the law of 1 price, if there are 2 prices for 1 thing, you should be able to exploit it. That will be an arbitrage. So we need to find out first 2 prices for the same thing. For that, we can use other prices, but I'm going to choose this one. I'm going to choose CAD MXN, directly available prices from the market, versus, so CAD MXN is given like this, 6.4390. I'm going to compute implied CAD MXN using triangular transactions. Using triangular transactions, using cross rate formula, if you multiply this by this, dollar will be canceled, and you will be able to compute implied CAD MXN. Looks like some students think this is very difficult. Well, if you understand everything in the review slide for lecture 1, I think this shouldn't be that difficult. But anyway, so we have 2 prices directly available CAD MXN versus the implied CAD MXN you just compute using triangular transactions. So this one price is going to be 6.4390. It's given from the market. This one is given. CAD USD, USD MXN, we already know what is that. CAD USD is this one. USD MXN is this one. So just multiply those 2. CAD USD, instead of that, we have this one. Instead of USD MXN, we have this one. and USD will be canceled. So this is the implied CAD-MXN. Number is this one. So what we just find out is there are two prices for one transaction. What is that transactions? Exchanging CAD for MXN. We have two different prices. So we have an arbitrage situations. Two different prices for the same transactions. You have an arbitrage case. Now, given these two numbers, so I'm gonna write down the number here, 6.4390. This one. So someone is asking questions. Could you have chosen to find the implied rate of USCAD USD? Yeah, that's right. So there is another way of solving this one. You can use CAD USD market rate versus implied rate of CAD USD using cross rate formula. You should get the exactly same answer. This one is a 6.1686. So you see this inequality. What is the meaning of this inequality? So you have CAD1. If you sell CAD1 here, you will get this amount of Mexican peso. If you sell CAD through triangular transaction, you will get only this amount of MXN. So for 1 Canadian dollar, you have to pay more Mexican peso. Here, you have to pay less Mexican peso. In other words, Canadian dollar is too expensive or overvalued using this rate because you have to pay more Mexican peso, while it's undervalued in right-hand side prices. So everything here is a relative sense. CAD is overvalued here. You have to pay more Mexican peso. CAD is undervalued here because you have to pay less amount of Mexican peso. I'm just repeating this one. So Mexican peso is undervalued in left-hand side, while overvalued in right-hand side. This this one implies this one naturally. So how do we exploit? Always you have to sell with higher price and you have to buy back with a lower price. So you are going to use CAD1. You have to sell it. You have to sell this one with higher price. CAD has a higher price here. So you have to sell CAD here to get Mexican peso. Or you could say something like this. For 1 Canadian dollar, you can get more Mexican peso. So you're gonna sell Canadian dollar here to get more Mexican peso. And once you get Mexican peso, using triangular transactions, you have to buy back Canadian dollar through these triangular transactions. So you start with the 1 Canadian dollar. You sell the Canadian dollar to get Mexican peso. Using triangular transactions, you end up with the Canadian dollar. Now, what you get after this process is bigger than your initial point. That's your arbitrage profit. So let's go through this step by step. So step one, you're gonna sell 1 Canadian dollar at market rate and get 6.4390 Mexican peso. Just numerical value. You're gonna sell Canadian dollar here to get 6.4390. Once you get 6.4390, many students seem to leave. Okay. You have to sell this amount of Mexican peso. How? You have to use triangular transactions. Using triangular transaction means you have to sell Mexican peso here. Then what is going to get is a dollar. So once you get dollar, you should sell it right away using this one. Then eventually you're gonna get CAD. So let me explain this one more time. You sell Canadian dollar to get Mexican peso, and you have to sell Mexican peso to get dollar, and you sell dollar right away to get Canadian dollar. So you start with the Canadian one, you get a Mexican peso, You sell Mexican peso, get dollar. You sell dollar to get CAD. So you start with the Canadian dollar. You end up with Canadian dollar. If this number is bigger than one Canadian dollar, then you get profit. That's what we are doing here. So one Canadian dollar, you sell one Canadian dollar to get Mexican peso. Right away, you're gonna sell that Mexican peso to get dollar at MXN USD. Then MXN will be canceled. You're gonna get US dollar amount. So what is MXN USD? We only have USD MXN. So MXN USD is just a reciprocal. So you sell Mexican peso this amount at MXN USD, you get US dollar amount. Right away, you have to sell this US dollar to get Canadian dollar amount. At which rate? It should be USD CAD. Then USD will be canceled and you're gonna get Canadian dollar amount. So USD 0.735591 times, what is USD CAD? Only CAD USD is given. So this one should be reciprocal of this guy, which is this one. This is the USD CAD, reciprocal of the CAD USD. So at the end, we're gonna get this amount of Canadian dollar. So in summary, you start with the 1 Canadian dollar, you end up with the more than 1 Canadian dollar. The difference is gonna be your risk-free profit from exploiting these arbitrage situations. So any questions? Given 3 sets of prices, when you have 1 Canadian dollar, you have to think about whether you have arbitrage opportunity here or not. In order to determine that, you have to first find out 2 different prices for 1 transactions. In this case, I used the transaction of exchanging 1 Canadian dollar for Mexican peso. Then using those 2 set of prices, we need to determine at which price Canadian dollar is overvalued or undervalued. Now, in order to exploit this arbitrage opportunity, you have to sell Canadian dollar at a higher price, and you have to use triangular transactions to buy back Canadian dollar at the end. That's the whole procedure. Okay, so any more question? Can you expect question like this on the exam? Yes, but the format is going to be MCQ. So I can transform this one into MCQ question, something like the first choice is 2 Canadian dollars. Second choice is 3 Canadian dollars. Third choice is the 1.043846 Canadian dollars, something like that. What is LHSN, right? Okay, so maybe you. So we are comparing market rate, the quoted price, CAD MXN, price for exchanging Canadian dollar or Mexican peso, which is this one, market rate, versus the implied the CAD MXN. So I said this is left-hand side, so LHS, and this is the right-hand side is RHS. So what other? Yeah, someone, right. So we just have 2 set of price, one directly available from market, the other one, you have to get it using cross rate formula. So if you have 2 different set of prices, now you can think about arbitrage opportunity. All right. Let's talk about question 4. The Mexican peso has weakened considerably relative to dollar, and you are trying to decide whether there is a good time to invest in Mexico. Suppose the current exchange rate is this one. So more familiar expressions. This. For 1 US dollar, you have to pay this 9.5 Mexican peso. We have 2 advisor A, advisor B. They produce their forecast about the future exchange rate. Now, advisor A said, Mexican peso price of the dollar will be 15% higher. What is the meaning of this one? Mexican peso price of dollar. I said dollar price of an apple. This means, let's say $1 per one apple, then $1 per apple. Or if the price is $2, then $2 per apple. What I'm trying to say is that dollar price of an apple should be written down like this. So apple is in the denominator, dollar is in the numerator. So when I say Mexican peso price of dollar, then dollar is in the denominator and Mexican peso is in the numerator. So this is the symbol for Mexican peso. So we can translate this expression into USD MXN. So Mexican peso price of dollar will be 15% higher. That means USD MXN, the currency in the denominator, will have 15% higher value in the future. So given USD MXN is 9.5, and I think USD MXN will be 15% higher. Dollar will be 15% higher. The currency in the denominator will be 15% higher. It means A's forecast of the USD MXN after 1 year is the 9.5 times, this is actually 1 plus change. Your change is plus. Why? Because the currency in the denominator will appreciate, will be higher. So sign will be plus. How much? 15%. So it should be 0.15. That's how we got this number. Current exchange rate times 1 plus change. Here, change means appreciation of dollar. So plus by 15% means 1.5. So 9.5 times 1.15 is 10.925. That's the A's forecast of the USD MXN. What about the B's forecast? B says dollar price of peso. Like this one, we can translate this form into peso should be in the denominator, dollar should be in the numerator. So MXN USD. So B says MXN USD will be 15% lower. So MXN will have 15% lower value. Now you may ask, these two look similar, right? Because Mexican peso price of dollar will be 15% higher. So dollar will appreciate by 15%. This one means peso will depreciate by 15%. But I talk about this one in the lecture slide. These two might not be the same thing, right? So the Greece case, you can use this one as to politically support some idea, right? You get different number for the same phenomenon, same in the event. So when you use USD MXN or when you use MXN USD, you will get different number, right? You need to remember that one. Anyway, so A forecast is going to be this one. What about the B's forecast? So given USD MXN is 9.5, we think MXN USD will be 15% lower. Now, when we think about the MXN USD, the appreciations or depreciation of Mexican peso, we have to use MXN USD, not USD MXN. So you have to be careful about this one. When we talk about appreciation and depreciation of dollar should be in the denominator. When you talk about appreciation and depreciation of Mexican peso should be in the denominator. So we need to translate first today's USD MXN into today's MXN USD, which is just reciprocal. So this is the today's MXN USD. And we think MXN USD will be 15% lower. That means MXN USD after 1 year is today's exchange rate times 1 plus or minus. The currency in the denominator MXN will depreciate. So the sign should be minus. How much? 15%, so minus 0.15. So this times 1 minus 0.15. This is how we got this expression. So this is the MXN USD after 1 year based on B's forecast. Now you might want to compare the USD MXN of A's forecast and B's forecast. Then we need to convert this one back into USD MXN term, which is reciprocal. So this is just reciprocal. We get this expression. So compare with the A's forecast, dollar will appreciate by 15%. We get this expression, 10.925. Now, peso will depreciate by 15%. That means actually USD MXN is 11.1765, two different number, right? So it appears that they are saying the same thing, but it's not. So we have to be careful. Anyway, in this question, the most important thing is how would you translate this one into this form? Mexican peso price of dollar, you should write down like this. Dollar should be in the denominator. Dollar price of a peso should be in the denominator. And we have to get the sign correctly. A's forecast case, appreciation of dollar. So sign should be plus. In B's forecast, Mexican peso should be 15% lower. That means this sign should be minus, right? There's a point you need to be careful. Any question? Okay. Let's talk about question 5. Deutsche Bank quote to bid ask rate like this. So what is the interpretations? Bid rate, ask rate. This is the interpretations. So bid price of EUR/USD is this one. Ask price of EUR/USD is this one. What is the interpretation? Dealer buy the currency in the denominator, €1, with this amount. Dealer sell currency in the denominator, €1, with this amount of dollar. Right? That's the interpretations. You should know this one clearly. And also we have bid ask price for USD JPY. So this is the bid price. This is the ask price. Dollar is in the denominator. Bid price of USD JPY is this one. Ask price of USD JPY is this one. What is the interpretations? Dealer buy the currency in the denominator, $1, with this yen. Dealer sell currency USD currency in the denominator, 1, and get this amount of Japanese yen. That's the interpretations. You should know this meaning. So given those sets of the ask and bid prices, what would be the Deutsche Bank's direct bid and ask price of the yen per euro under no arbitrage? So we are supposed to use these conditions. In fact, we learned this one in the class. How do we get the exchange rate of these two given two exchange rate, EUR/USD? That's this one, EUR/USD. This one is the USD JPY, right? Given these two, how do we get the exchange rate EUR/JPY? That's the cross rate formula. But in the lecture, we talk about cross rate formula without thinking about bid and ask price. Here in this question, you are supposed to compute bid price of this one with this bid and ask price of this, and ask price of this one using bid and ask price of this one. More realistic case. How do we do that? So that's the question 5. So let's decompose what you are doing. What dealer is doing. When we think about bid price of EUR/JPY, what dealer is doing is dealer buy 1 euro, the currency in the denominator, by selling certain amount of yen. So we are supposed to compute this number. That's the bid price of URJPY. That's the first answer, right? We are supposed to compute bid price of URJPY and ask price of URJPY. Here, we are trying to compute bid price of URJPY. And there's a hint. We have to use cross rate formula. So we're going to use cross rate formula to come up with a formula explaining how to compute bid price of URJPY and ask price of URJPY. In order to do that, we are gonna decompose this one transactions. So there is a question. Why do we want URJPY? So it says yen per euro. So for 1 euro, how many yen you need? Yen per euro. Because of this one, we are trying to compute EURJPY. How many? Is this okay? So using triangular transaction, we are going to do the same thing. So take a look at this one. Buy 1 euro by selling certain amount of yen. We can do this one with two different transactions. We buy 1 euro, we sell yen, that's the end part, the starting part. Using triangular transaction, so USD will be in the middle. So buy selling dollar, buy buying dollar, this one will be canceled. So without these two, you achieve exactly same thing. So this is something like the market rate versus implied rate, right? The implied rate, implied bid price of EURJPY. What we are trying to do is the buy 1 euro by selling yen. We can do that by using dollar in the middle. So we're gonna do buy 1 euro by selling yen, but in order to do that, we're gonna use dollar in the middle. So buy 1 euro by selling dollar, right away you buy that dollar by selling yen, right? So we are decomposing this one transaction using two transactions, triangular transactions. So here, in terms of dealer point of view, this is the bid price of EURJPY. Dealer buy 1 euro at bid price of EURJPY. What is this one? Buy 1 euro by selling. This is the bid price of the EURUSD. Dealer buy the currency in the denominator with this amount of dollar. What about this one? Dealer buy dollar, so bid price of USD/JPY. Dealer buy the currency in the denominator with this amount of yen. Is this okay? So we're using still triangular transaction. We have two exactly same, one exactly same transaction with two different ways. One, you're exchanging EUR for JPY. Number two, you use USD in the middle, but USD will be canceled. We're gonna talk about this one in terms of bid price and in terms of ask price. In terms of bid price, we can decompose the whole process into two. Dollar is in the middle, and think about which price will be used for each transaction. So the bid price of this one should be equal to bid price of this one times bid price of this one. So at the end, once you understand this logic, memorizing this one is very easy. You still use the same formula. Bid of this one is equal to bid of this one times bid of this one, right? You memorize cross rate formula. Bid is equal to bid times bid. Well, next slide, I'm going to show you ask is equal to ask and ask, right? So the bid price of URJPY is just the multiplication. This is the number. Ask price, so we are gonna use exactly same logic. Ask price of EURJPY. The dealer is going to sell EUR, 1 EUR to buy certain amount of yen. We still use triangular transactions. So sell €1 to buy certain amount of yen. We can decompose this one by using US dollar. So sell €1, buy Japanese yen. First point, last point. In the middle, we have dollar. So when dealers sell €1 to buy Japanese yen, they're gonna use this price, ask price of the currency in the denominator. When they sell €1 to buy dollar, they're gonna use this one, ask price of USD. They sell €1 to get dollar amount. When they sell dollar to buy Japanese yen, they're gonna use this price. They sell $1 to get Japanese yen at the ask price of this one. So the ask price of this one is just this one times this one. Numbers are given. So at the end, this is the formula with transaction cost. You have to put bid, bid, bid. That's first formula for bid. Second formula for ask. Ask is equal to ask times ask, right? So understand the logic. Memorize the formula. You don't even have to memorize because everything is going to be open book exam. So you can just write down the formula for you when you try to solve MCQ questions. Any question up to this point? Okay. Now the question 6, Baker Hardwick, chapter 2, question 6. There's one question. Will the whole exam be MCQ? I think you missed watching my welcome document. There I explain there are two sections. One section is MCQ, topic 1 to 3. There will be 15 questions based on topic 1 to 3 MCQ questions. Section B, there will be one short question. You are supposed to choose one out of two. So each question will be based on the topic 5 and topic 6. So one question based on topic 5, the other one is based on topic 6. By the way, the practice question, I should say the most of MCQ question will be similar to what you see now. Just different format. It's almost similar question, but I'm gonna give you several choice you can choose MCQ format. The question itself will be similar. So if you are able to solve all practice question and also two past year exam questions, which are already posted on Blackboard, I will explain about how to solve them in the future. If you are able to solve everything there, you should be able to solve at least more than 80% of the MCQ question. The forms are similar, the contents are similar, but forms are gonna be, the MCQ format will be used. Anyway, the question 6. This company has called Mitsubishi Financial Group to get its opinion about the Japanese yen, Australian dollar exchange rate. Current rate is going to be is this one. This is the symbol for Australian dollar. So I can use this expressions. AUD/JPY is equal to 67.72. A dollar, Australian dollar is in the denominator, yen is in the numerator. For one Australian dollar, this is the yen amount, right? And then Mitsubishi think the Australian dollar will weaken by 5%. When we say Australian dollar will weaken by 5%, they are using AUD/JPY. The currency in the denominator will depreciate by 5%. So the change will be minus 0.05. Depreciation of AUD by 5%. So AUD/JPY after 1 year is going to be current exchange rate times 1, Y minus. The AUD will depreciate, so minus sign by 5%, 0.05. So this is the number. This is almost same as the previous forecast question. So I don't have to repeat my explanation on that. Okay. Now, Baker-Hardwick, Chapter 3, Question 1. The spot exchange rate of yen relative to dollar is this one. So for $1, you need to pay this amount of yen. 90-day forward rate is this one. For $1, you have to pay this one. So you have to pay less amount of dollar, less amount of yen for $1 in the forward market. You have to pay less for $1 in forward market. That means dollar has a forward discount. Dollar is discounted in the forward market, right? So dollar is at a forward discount. We need to compute premium or discount as a percentage and annual term. This is the formula we learned. 100 for the premium, the percentage, sorry. 360 is for 1 year, so N is the maturity. We are using 90-day forward, so this one should be 90. And we are supposed to compute F minus S over S. Now, you need to be very careful when we talk about for the premium or discount on dollar should be in the denominator. When you compute this one, dollar should be in the denominator. Let's say I ask you to compute for the premium or discount for yen. Then you cannot use this formula. You have to put yen in the denominator, right? You have to use reciprocal everywhere. So that's the important part. When I ask you to compute for the premium of dollar, you have to use the exchange rate. The denominator should be dollar. When I ask you to compute discount and premium for yen, yen should be in the denominator. Anyway, the computation itself is very simple. So here minus means the currency in the denominator, dollar, is discounted. Dollar minus means discount at forward market by this amount. Question 2. Now we have table for many exchange rates. So this is the spot exchange rate. This is 30-day forward rate, 60-day forward rate, different maturity. So this is the exchange rate for EUR JPY, which means, so for, what about this one? This means for €1, you have to pay this amount of yen. This one means for €1, you have to pay this amount of yen. Now, in a forward market, you have to pay less amount of yen for €1. €1, you have to pay this amount. €1, you have to pay this amount. You pay less amount of yen here. So euro is at a forward discount, just like the first question. So it's not that difficult. Let's compute forward premium or discount for 30-day forward. We use the same formula. Maturity is 30-day. So percentage term, 1 year, maturity, F minus S over S. We are computing premium or discount of the euro. So euro should be in the denominator, which is this exchange rate. So we can just use this exchange rate here because euro is already in the denominator. But let's say I ask you to compute the forward premium or discount of yen, JPY. Then you have to use the reciprocal everywhere, right? This should be very clear to you. Anyway, this is easy because you can just directly use the number here. Just the forward rate for 30-day is this. Spot rate is this. Spot rate is this. So we get minus 4.51. Minus means discount. The currency in the denominator, euro, has a discount by this amount. Question 3. This is how we actually see the spot rate and forward rate in the real market with bid and ask price. So previously, we assumed there's no bid ask price. Just one number is given for each transactions. So chatting window. Why are we using some 30-day figure instead of 30? You can use anything. This is an example. So if I want to compute 360-day forward, I want you to exercise with this one. For each different maturity, you should be able to compute this number. If I want to compute this premium or discount for 360 days forward, I can use 360 here, and F should be this one, right? Very easy. So this is just example for 30-day. You can compare like this. For 360-day, you have to put 360 here, and forward price should reflect that, right? Just an example. BH chapter 3, question 3. So we have B-desk price everywhere. The first row is EUR USD. So for 1 euro, how many US dollar you have to pay? Now for spot, 1 month forward, 2 months forward, 3 months forward, 6 months forward, we have two different numbers. We call this as a forward point, not price, forward point, forward point, forward point. And here, first one is the bid price, and second one is the ask price. The interpretation is 1.0435. So last two digit should be reflecting the last two digit, this one. 1.0435 is the bid price. 1.04 same, but we replace last two digit with the 45. 45, this is the ask price. Bid price, ask price. This is how you actually see the prices in the market. First one is the bid, second one is the ask price. First one is the bid, second is the ask price. Bid and ask, right? Now, how do we get the forward price from this table? So for example, what are the forward bid and ask quote or prices for the EUR USD at the 3 months maturity? So 3 months maturity, we have 75 and 90. Now using spot rate and this one, so-called forward point, using this one and this one, you should be able to get forward price. Now, sometimes the second one is bigger than first one. 75 is less than 90, but this case, first one is bigger than second one, right? So we have two different cases. This one means the first number is less than second number, just like this one. EUR USD at the 3 months maturity, we have this case. First one, so we use X for the first one, second one for the Y. Y is bigger than X. Then forward bid quote, bid price is the spot bid price, which is 1.0435 plus last two digit of the 0.0075. In other words, this is a basis point. 0.0001, this is 1 basis point. So this is 75 basis point. The 75 means 75 basis point, which is this one, 0.0075. So you have to add it. You have to add it. 75 to bid, 90 basis point to ask. What about this? If X, the first one is bigger than Y, you have to subtract this one from bid price. You have to subtract this one from ask price. If you read the instruction in the practice question for this one, the Baker-Hardwick chapter 3, question 3, you will find the old explanation there. But you need to just know this one. If for the point, the first one is less than the second one, you have to add that to the spot rate to get forward rate. You just need to, you should be able to get forward price bid and ask using spot bid and ask plus this forward point. B, if one of your corporate customer calls you and want to buy pound, this sentence means you are a dealer, right? Corporate customer calls you and they ask, what is the price you are going to quote? So you are the dealer here. You are setting the price for them. And they want to buy pound with dollar. So we are exchanging GBP for USD. So it involved with this one, right? GBP, we are exchanging GBP for USD. And customer want to buy. In terms of view, in terms of dealer point of view, in terms of dealer point of view, you are selling. So dealer is selling pound for dollar. That should be ask price of GBP USD. dealer is selling the currency in the denominator for dollar at ask price, right? So this question asks you to compute ask price of GBP USD given this table. So how do we get that? So ask price means the second ask price spot rate and the X is less than Y. So you have to add 110 basis point. So 1.66 last two digit will be replaced by this one. That's the ask price, 1.6633 plus you have to add 110 basis 6 months, sorry. So this is 3 months, 6 months. So 130 basis point, 0.0130. So this is going to be ask price of the GBP USD for the market, 6 months, right? So this is how we actually interpret, get the number there. Now, Baker-Hardwick, Chapter 3, Question 4. Intel is going to receive a payment of 100 million yen in the future. Okay, given these situations, what is the Intel's FX risk? Transaction FX risk means the FX risk coming from export or import transactions. You will learn more about this one in the second semester anyway. So what is the Intel's FX risk? Now remember, Intel is a US firm. They are going to compute profit in dollar term, right? They are going to get yen amount for sure. So this amount is fixed in the future. The problem is this amount is unknown in terms of dollar. So if the exchange rate, if yen depreciate or dollar appreciate, that means this yen amount, when you translate that into dollar amount will be lower, smaller, right? When yen depreciate to dollar, Intel will get less amount of dollar in the future. That is the transaction FX risk. Because of unknown exchange rate, Intel is worried about getting less amount of dollar in the future. It's the answer for this one. Now, current exchange rate is this number is given, and analysts are forecasting that dollar will weaken by 1% over the next 90 days. Dollar will weaken by 1%. So this is the actually opposite of this case. Intel will lose if yen depreciate. But if dollar depreciate, they will get more dollar. Many students are confused about this one. Given this forecast, you may think there is no risk for Intel because the forecast is actually opposite of the risk of Intel. Intel is worried about yen depreciations, but when dollar depreciate, actually yen appreciate, so Intel is going to get more dollar. So there is no risk. That's not the case. Remember, this is the mean forecast. Exchange rate, we talk about this one in the lecture. Mean is just this one number. We have whole distributions. So this is the forecast, average forecast, but the actual exchange rate can be any number. Even though your forecast is this one, anything can be realized. That's the risk we are worried about. So you have to be careful. Even though mean forecast says there could be something you can get from dollar depreciation in this case, in fact, you can still worry about the future exchange rate because anything can be realized. So there's a question. Because Intel is US firms, your profit is going to be computed in dollar term. So let's say Japan Japan is going to bankruptcy. No one is going to accept Japanese yen, right? Then you lose everything. Okay, so then if Intel choose not to hedge its transaction exchange risk, they are not gonna use forward contract to remove FX risk. They're going to just expose to risk. What is Intel's expected dollar revenue? With the belief that analysts are correct. So mean forecast will be realized. Then what is the expected dollar revenue? So they will get 100 billion yen for sure. We have to convert this one into dollar amount. So we are going to compute dollar revenue, expected dollar revenue. In order to convert this one into dollar, we need JPY USD after 90 days. If you convert 1 million yen into dollar, you need JPY USD 90 days from today. You need expectation of this exchange rate. By multiplying this one with this expected rate, you will get dollar amount. Is this okay? We are supposed to compute expected dollar revenue. Now we know for sure the Intel is going to get 1 million yen. Now we have to convert this one into dollar. When we convert yen into dollar, you need JPY USD. Then yen will be canceled. You're gonna get dollar amount. So we need the exchange rate from 90 days from today. And if you get expected rate, by multiplying these two, you're gonna get expected dollar revenue. There is a questions. Why would not use the reciprocal of JPY/USD to get the dollar figure? Yeah, we're gonna use that. So we need to first think about expected value of USD JPY after 90 days. In order to compute this one, once we compute this one, you can get ET JPY USD using the reciprocal. So given this forecast, dollar will weaken by 1%. We can get analyst forecast in terms of USD JPY 90 days from today. Current exchange rate times 1 plus expected change. Now, dollar will weaken. Currency in the denominator will weaken. So this one will be minus. Dollar will depreciate minus by 1%, so minus 0.01. That's what we are computing here. So 103, current exchange rate times this one, 1 minus 0.01. This is the analyst forecast about the future exchange rate USD JPY. But in order to compute expected dollar revenue, we have to multiply 100 billion yen with expectation of JPY USD. We know expectation of USD JPY, so we're going to use reciprocal. Now, this is approximations. So some of you are familiar with this one, the expectations of something, EX. Reciprocal is not this one. There are some numerical errors, but I'm going to just ignore that. I'm going to just use the reciprocal like this. ET/JPY/USD is the reciprocal of the ET/USD/JPY. So if you multiply like this is the expected dollar revenue. Now, this is the last question. So I'm going to go slightly over the time limits slightly. If Intel does not hedge, what is the range of possible dollar revenue? The dollar revenue that incorporate 95% of the possibility. We're going to assume normal distributions. The dollar revenue, how do we compute dollar revenue? 1 million yen times JPY USD 90 days from today, right? This one will give you dollar revenue. If you want to compute expected dollar revenue, you have to put expectation here. If you want to compute just dollar revenue, you don't need expectations. This times this is going to be your dollar revenue. Now, whenever you see this kind of question, you need to start with the getting 95% bound of USD JPY. USD JPY. In the question, USD JPY is given. In the question, the dollar, the currency in the denominator in USD JPY weakened by 1%, and then percentage depreciation of dollar. Everything is written in terms of USD JPY. In this question, this is written as USD JPY. We are talking about dollar will weaken by 1%. This means dollar is in the denominator. Depreciation of dollar, this one also means dollar is in the denominator. So given these information, what you can get is actually 95% bound of this one, which is USD JPY from 90 days from today. You can get this bound. How? You have to compute mean first. We just compute the mean forecast. What we are computing is this one, the distributions of future USD JPY. We have mean. Once you compute standard deviation of this guy, these distributions, ST plus 90 USD JPY, using those mean and standard deviations, we can get 95% bound. So you should remember this one. Within 1 sigma, this is mean, which is 101.97, plus 1 sigma minus 1 sigma. This is 68%. Plus 2 sigma minus 2 sigma, that's the 95% bound. So mean plus 2 times standard deviation. How do we get standard deviations? Standard deviation of future exchange rate of USD JPY is today's exchange rate times standard deviations of change. So the last sentence here, standard deviations of 9-day forecast of the depreciation of dollar. This actually means standard deviation of change. 4% means 0.04. So today's exchange rate times 0.04 is 4.12. So this is standard deviation. This is the mean. So mean plus 2 times standard deviations, mean minus 2 times standard deviation, that's a 95% bound. So which is these two, lower bound and upper bound. So 95% bound, 95% of value will appear here. Low one is 93.73. Upper one is the 100.21. Given mean and standard deviation, we can get these distributions. Now the problem is, what you are trying to get is the 95% bound of 1 million yen times JPY USD 90. What we have is the 95% of the USD JPY. To get 95% bound of this whole thing, yen amount times JPY USD T plus 90, you have to get this one first, JPY USD T plus 90, 95% of bound of the JPY USD. So let me say one more time. In the previous slide, we got 95% bound of this one, USD JPY. Given 95% bound of this one, we compute first 95% bound of this. And then you just multiply 1 million yen to low and upper bound of this one. That is going to be your answer. So 95% of JPY USD is a reciprocal. Why this is reciprocal? The previously, this here, 93.73, 110.21. That's the 95% bound of this one, USD JPY. Now 95% of USD JPY reciprocal. reciprocal of this one, reciprocal of this one. This one will be bigger than this one, right? Reciprocal of smaller one will be bigger. Therefore, 95% of bound of JPY/USD, 1 divided by lower bound of this one, 1 divided by upper bound of this one, USD JPY. This is going to be 95% of the JPY/USD. You're gonna multiply these two numbers, each one by 1 million yen. 1 million, 100 million yen, 100 million yen times lower bound, 100 million yen times upper bound. So this is going to be 95% bound of the dollar revenue. So this question, let me summarize a little bit. Every information is given for future USD JPY. Given forecast about the mean, you can get mean forecast about this one. Given changes, the standard deviations of change, 4%, you can get standard deviations of future exchange rate, USD JPY. Once you get mean and variance or standard deviations, you can get 95% bound for this guy. But that's the first step you have to take. First, get the future distributions of the exchange rate. And then step 2, you have to think about which bound you are computing. You are computing bound of 100 million yen times, not USD JPY, USD JPY USD. Then you have to think about relationship between this one, the ultimate goal, with the exchange rate distribution you just compute. You just compute 95% bound of USD JPY. How can we use this one to get 95% bound of this one? You have to use reciprocal to get 95% bound of JPY USD. And then you have to multiply by 100 million yen. You will see the similar question in, I think, in one of the topic 2 questions. You will be able to exercise this one more time.